Well, good morning, good afternoon, good evening, good 3 o'clock in the morning, good 5 o'clock in the morning, good wherever you are and wherever this finds you. This is getting intense. Here we go again. Now today, I want to talk about some of the things in your book, continuing to talk about form and validity, and to try to help you think about the things in the book. I want to add some things to what the book is saying that I think make it clearer. All right, so we're going to be looking at this section of your book in Chapter 1, essentially page 30 to page 40. Okay? And the first thing we want to think about is how the author of our text tells us to think about getting at the form of an argument, which we've already talked about a little bit. He asked us to consider A and B here. All dogs are cats, all cats are snakes, therefore all dogs are snakes. No mammals are beagles, no mammals are dogs, therefore no beagles are dogs. And he asks us to think or consider that in categorical logic, a statement form is an arrangement of logical vocabulary and letters that stands for class terms, such that a uniform substitution of class terms for the letters results in a statement. For example, if we let D equal dogs and C equal cats, then the statement form is all D or C. We can extend the technique, to reveal the argument forms of A and B, which we will then label FA and FB, form of A and form of B. And here are the letters we will use. We can call this our dictionary, or our key. Let D equal dogs, C equal cats, S equal snakes, M equal mammals, and B equal beagles. So that gives us all D or C, all C or S, all D or S. And for B, no M or B, no M or D, no B or D. And we can call this translating it into symbolic form. But now we want to add a step and put that symbolic form into universal form using propositional variables. Remember in an earlier lecture I said that in modern logic, propositional variables are indicated by using the small letters of the alphabet beginning with P. And so we could take this argument, this particular argument, all D or C, all C or S, and all D or C, and put it into a universal form where we abstract from any content like dogs, cats, and snakes, and just essentially put up our boxes and our circles, or it's like putting in X's and Y's in a mathematical formula, right? And when you do this, you sort of run through, beginning with P, Q, R, S, T, U, R, V, depending on how many class concepts you have in your argument, and you substitute them one by one. So if I were doing this on paper, I would put a little P by the D, and then I had a new one, so it would be Q, and then C is Q, and then S is R, and then D, of course, is P, and S is R. And that gives us the universal form of the thing. All P are Q, all Q are R, all P are R. And this is a valid argument form, which means that if you put the same things in the P's, the same things in the Q's, and the same things in the R's, you can never go wrong. If the premises are true, it would have to be true. Now in the second logic course, symbolic logic, which you could take in the spring with me if you want, we would learn how to prove this is a valid argument form. But for right now, you just have to take my word for it. Right? But you could put in there anything you wanted, right? You could put in all cows are grass eaters, all grass eaters are flatulent beasts, therefore all cows are flatulent beasts. Or you could put in all stars are very hot things, all very hot things are things that will burn you, so all stars are things that will burn you. You can put in whatever you want, and it will always come out valid. So following along with what we're adding to our author in the book, he gives us the form of B. He gives us the symbolic form, which becomes no mammals are beagles, no M or B, no mammals are dogs, right? No M or D, So no beagles are dogs, no B or D. And again, we have P, Q, P, R, Q, and R. No P or Q, no P or R, and no Q or R. So we could actually call this the UFB, the universal form of B, I guess. Let me add that in right now. We'll call that the universal form of B, right? And this is an invalid argument form. And again, if you take symbolic logic with me in the spring, we'll learn how to prove that it's an invalid argument form. But for right now, it means any argument which has this form is just a bad argument. Professor Baronet then asks us to consider the following deductive argument. Deductive argument C. All boomas? I don't know what that is, right? All bomas are scam artists. All grifters are scam artists. All bomas are grifters. He says you do not need to know what either a boma or a grifter or a scam artist is in order to determine if the argument is valid or invalid. Whatever those things are, we can begin by thinking about the argument in a logical way. The argument relates two things, bomas and grifters, to a third thing, scam artists. Now, even if we assume that every boma and every grifter is a scam artist, is it necessarily true that every boma is a grifter? The first step of the analysis is to translate it into symbolic form. So he's going to make a dictionary. He's going to let B stand for bomas, S for scam artists, and G for grifters, which gives him the symbolic form of C. All B are S, all G are S, all B are G. But we want to put it into its universal form using propositional variables. So we can see the form more easily and more easily compare it with other things. Right? So here we see it becomes all P are Q, all R are Q, so all P are R. And one way to show that this is an invalid argument, before you take symbolic logic with me in the spring and learn how to prove it, is to give a counterexample. A counterexample is one that has the same form, same universal form as the original argument, but when you plug everything in, it makes it such a bad argument that everyone can clearly see how bad it is. Right? So here we're going to make a counterexample. Now, all bomas are scam artists, all grifters are scam artists, so all bomas are grifters has the form all P are Q, all R are Q, and all P are R. So if we let P if we plug in beagles for P, mammals for Q, and dogs for R, that gives us all beagles are animals, all dogs are mammals, so all beagles are dogs. But that didn't work, did it? Because it's true that all beagles are dogs, all dogs are mammals, and all beagles are mammals. Oh my God, that didn't show us that it's invalid. That's why you need to take symbolic logic with me in the fall, because there's a hell of a easier way to do this. But we're not in a position to know it yet. So what can we do? What does Professor Baronet tell us to do? And he's going to give us some good advice. Let's read along with him. Truth-value analysis shows that the premises and the conclusion are true. So this substitution instance is not a counterexample. At this point, it can help to change our strategy so our thinking does not get stuck in a loop. Repeating the same approach to a problem may cause us to miss other possibilities. We might fail to see alternative paths because our minds are locked into one way of analysis. Sometimes, however, the light bulb goes on and we instantly see the answer, the aha experience. A puzzle illustrates how this can happen. Imagine that you're given a knife and are told to cut a cake with no icing into 2 equal pieces with 1 slice. You must always cut the cake in straight lines. You cannot stop a cut halfway through the cake and resume it at another place, and you cannot touch the cake in any other way. This is easily accomplished as follows. Cut that sucker in half. Now, once you've successfully cut the cake into 2 equal pieces, you are then asked to cut the cake into 4 equal pieces with 1 more slice. You should be able to do this quite easily, right? At this point, you are now asked to cut the cake into 8 equal parts with this 1 more slice. Remember the rules. You must cut the cake in straight lines. You cannot start a cut in one place and resume it in a nut somewhere else. And you cannot touch the cake in any other way. Can you do it? I mean, if you did it this way and that way, that'd give you too many pieces, wouldn't it? That's not going to work. Now, before reading further, you should have struggled with the problem for a while in order to experience fully the possibility of attacking the problem in only one way. The puzzle, as stated, has set your mind to thinking in one direction by imagining the cake as a two-dimensional object. In other words, I'm thinking, well, what if I cut it like that? But it's got to be in equal pieces. So what if I cut it like that and like that? Well, then there's too many pieces. But remember, the cake is a three-dimensional object. It can be cut in half through the middle, leaving 4 pieces on top and 4 on the bottom, all equal to each other. If our search for a counterexample starts with the premises, then we start by making the premises true and then seeing if the conclusion turned out to be false. Although it is generally easier to think of things that would make the premises true, we could get stuck in a loop. However, there's a way to shorten the amount of time needed to find a counterexample, and that's to analyze an argument from the bottom up. This technique temporarily ignores the premises and instead concentrates on the conclusion. For our current example, the conclusion is all B are G. Since we are searching for a counterexample, we must substitute terms that make the conclusion false. It helps to use simple terms that will make the conclusion obviously false. For example, let's try the following substitutions, and where there's a B, put men, and with G, put women. It's obviously false that all men are women, right? So there we have a false statement, and now we're going to try to make the other two true. Right? Now, if we can substitute a term for the S in the premises and have the premises be true, then this will produce a counterexample. But before we start trying to before we simply start randomly trying different terms, we should think of what we are trying to accomplish. We need to substitute something for the S such that both premises are true. That means we have to think of something that both men and women have in common. Well, since every man and every woman is a human being, we can try that and see what happens. Suppose we then said, all men are human beings, all women are human beings, all men are women. Right? That first premise is true. All men are human beings. That second premise is true. All women are human beings. But clearly, not all men are women. That shows us that there's something wrong with this argument. Let's look at it using our universal form to help clarify matters. Here we have all Bamas are scam artists, all grifters are scam artists, so all Bamas are grifters, right? And that has the form all P are Q, all R are Q, all P are R. But so does this have that form. All men are human beings, all women are human beings, all men are women. Now you might just want to write that down and stare at it for a moment, right? Until it becomes clear in your head. And now let's apply this technique I'm using to one of your homework problems that I will assign to you, right? Here's number 2. No skyscrapers or buildings made of steel. No skyscrapers or towers less than 200 years old. Therefore, no buildings made of steel or towers less than 200 years old. So if we let S equal skyscrapers, B equals buildings made of steel, and T equals towers less than 200 years old, then we can give the symbolic form, we can translate it into a symbolic form in the following way. No S or B, no S or T, no B or T, and then we want to put it in universal form. No P or Q, no P or R, no Q or R. We can then think of a counterexample, right? The one the author thought of is, he says, well, no cats are mammals. That's true. So then we're going to put cats that we have there. No blank are cats, right? And no blank are mammals. And, well, no motorcycles are cats, no motorcycles are mammals, therefore no cats are mammals. But we know all cats are mammals. Clearly, this is a bad argument, and there's the form of it. Both premises are true and the conclusion is false. That's what a valid argument is. One where it's possible, where there's at least one possible instance where you have all true premises and a false conclusion. Therefore, the counterexample shows that the argument is invalid. Okay, so that's the first part of my little investigation into the text, reading it with you. I'm about to go into the next section now, but I'm going to stop here because I want to try to put this in little chunks you can use and think about and maybe watch again and try to take in. That's the one benefit I can think of this thing over Classroom. Because I wouldn't let you record me in the classroom, but now you have my lecture recorded. You can watch it as much as you want. Speed it up, slow it down. I suppose you could even, if you know how to manipulate video, put a funny hat on me. If you do manipulate the video, you might want to add some hair. Well, whatever. I have to amuse myself somehow here with my, well, not dad jokes, but we could call them granddad jokes. All right, so I'll be coming at you real quick with another video looking at Baronet's book and adding in the idea of universal form. Thank you for your kind attention.